Welcome everyone. In the previous class we were dealing with this light reaction, what are the events which takes place in the light reaction, as well as we have seen how electron transport system work. What is electron transport? So here the electrons the electron which is ejected from this chlorophyll, it will be passed on to a primary electron acceptor, and from this primary electron acceptor it will be passed on through to another series of electron acceptors. So this whole chain where electron is passed from one acceptor to another acceptor, that is called as what? Electron transport system, or we can even call it as electron transport chain. So now today in this class we will see, we'll move on further from this what we have discussed in the last video. So here in this last video what we have discussed is both this photosystem works during the process of photosynthesis. Both the photosystem work together, and here if this is the chlorophyll A and this is the chlorophyll A. So here this is the light harvesting complex. Light harvesting complex, it is nothing but it is made up of chlorophyll and accessory pigments. So this is one light harvesting complex, and this is second light harvesting complex or antenna complex. Light harvesting complex or antenna complex. So here these two complexes with this primary electron acceptor. Primary electron acceptor, and here also primary electron acceptor. Okay, so now this makes this photosystem 1 and this makes the photosystem 2. So here when this light falls from this sun, so here when the light falls it will receive light of, this is photosystem 2, okay, and this is photosystem 1. This is photosystem 2 and this is photosystem 1. So here what happened is, so here when the light falls on this, when the light falls on this reaction center as well as this reaction center, so when sunlight falls, so this absorbs, so wavelength of which one? 680 nanometers, it will absorb of 700 nanometers. So here both these harvesting centers, both these reaction centers or light harvesting complex or antenna complex, it will absorb the energy from the sun or absorb the light from the sun. So it absorbs light of 680 nanometers and it absorbs this light of wavelength 700 nanometers. So both those complexes. So what happens? So when it absorbs the light, it ejects one electron. It ejects one electron, and this electron is accepted by primary electron acceptor, as well as this also ejects one electron which is accepted by primary electron acceptor. It is accepted by primary electron acceptor. So now what happens? This acceptor will be, from this acceptor electron will move to a series of electron acceptors. It will move to a series of electron acceptors, that is cytochrome is there, phyophytin will be there. So now it will move to electron acceptors through different electron acceptors. So now what happens is, so when this electron moves, electron was ejected, now the electron is here, okay. Now from here it will pass on to this one, it will pass on from here, it will pass on to this one, from here it will pass on to this one. So when it comes here, now the electron loses energy, the electron loses the energy. Okay, so now here what happens? This energy will be trapped by ADP. The energy will be taken up by this ADP and this inorganic phosphate will be there, by taking this, the electron releases the energy. When it comes down the hill from this primary electron to after passing through a series of electron acceptors, when it comes down the hill, so what happens is it will release the energy. It will release the energy. Now when it releases the energy, that energy is taken up by this ADP and this phosphate. That energy is taken up by this ADP and it will combine with the help of that energy. ADP will combine with inorganic phosphate and what is formed is ATP. ATP will be formed. When this electron comes down the hill, it releases the energy. With the help of this energy, with the help of this energy, this ADP and inorganic phosphate combines. So because of this combination, what is formed is ATP is formed. So here ATP, we all know it is a energy rich molecule. It is a molecule which stores the energy. Okay. Now here ATP will be formed. Apart from this, so now what happens is, so this electron will move on to photosystem 1. This electron will move on to photosystem 1. Okay. Now it has lost the electron. Now this electron goes back here. Now this chlorophyll has got the electron. This electron which has been ejected earlier by this chlorophyll. Okay. So it will pass on to another acceptor and from here it will be taken up by NADP plus. Okay, it will be taken up by NADP. Here another that is another oxidizing compound will be there. So now this electron, it will move on to another electron acceptor from primary electron acceptor and from here this electron goes to this one oxidizing agent, that is NADP. Now this has got back the electron. So now what happens is, so if we see this one is called as the Z scheme of that is Z scheme of light reaction. So how it is happening? So this is this, then passing to this and then here. It will be accepted by finally here, that is by oxidizing agent. So what we have got is this, this and this. This is this one, then coming down the hill, then again going up. So here this one, it represents, if we see it from like this, it will represent the letter N. But see it like this, you just see it like this, this and this. So it represents the letter Z. It represents the letter Z because it is starting from here now, that is here, from here to primary electron acceptor to passing of this series of electron, then again this electron moves up. So this one, so because it will be finally accepted by oxidizing agent here, that is NADP. So now till here. So this and this is called as the Z scheme of light reaction. What it is called as? Z scheme of light reaction. Now coming to this one, this chlorophyll has got back its electron. So what happens here? This chlorophyll has not got the electron. So when it does, it cannot be like this without electron for a long time. It needs its electron back. So what happens is, so when it takes the energy now, with the help of the sun energy, water is there. Water molecule will split up. Water molecule will split up into that is 2 electrons plus a pair of electron plus a pair of proton plus oxygen atom. oxygen atom. So instead of this I will write half, that is 1 atom. So O is equal, that is usually we call it as O2. Now O0 we cannot just write O. So instead of this I will write it as half O2, that is 1 atom of O2. I will just write here. So when water molecule breaks, when this said but is by taking the energy from the sun, so with the help of the sun, with the help of the energy from the sun, water molecule is also breaking down. So this is called as what? Photolysis. What it is called as? Photolysis. Photo means with the help of light. Lysis means breakdown, breaking down or splitting. Lysis means breaking down or splitting. So here by taking the energy from the sun, this water molecule is broken down. When water molecule breaks, it releases a pair of electron, a pair of protons and an oxygen atom. So what we have till now, what we have got? So electron, proton and oxygen. So now this oxygen will be evolved. The oxygen will be released in the atmosphere back. The oxygen will be released in the atmosphere. So now what is present is electron is present and proton is present because it has been released. It has been released into the atmosphere. Leaves have released it into the atmosphere. Now what is present? We have this electron, we have this proton. This electron goes to this chlorophyll. This chlorophyll takes this electron which we have got by the splitting of water molecule. So because now chlorophyll was having 1 electron less, now it will get its electron back from the water, from the breaking of water molecule. Okay. So now the chlorophyll has got the electron back. This chlorophyll has also got the electron back. This chlorophyll has got the electron from where? From photosystem 2. And this chlorophyll has got the electron from this breaking of water molecule. Now both the chlorophyll have the electrons. Okay. Now electron is gone, O2 is released. What we have left is that is protons are left. So now these protons will be taken up by this NADP plus and it will be reduced to NADPH plus H, or we can even write it as NADPH2. So now this has accepted the protons and it has changed to NADPH plus, that is NADPH plus H plus, or we can even write it as NADPH2. So now what events has taken place? This light reaction, we have written it in the previous class, that is absorbing of light, then splitting of water, release of oxygen and ATP and NADPH2 form. So now the first absorbing of light, this light has been absorbed by this light harvesting complexes. So absorption of light has taken place, and because of that absorption of light, here this water molecule has broken down. So this process by which splitting of water molecule or breaking down of water molecule into, that is protons, electrons and an atom of oxygen. So this process is called as photolysis because the splitting is taking place in the presence of sunlight. Because if sunlight is not there, water molecule cannot be broken down. Water molecule can be broken down only by absorbing the energy from the sun. So here, because of this energy, the water molecule is broken down into electrons, protons and oxygen. Oxygen is released. So now here we have seen absorbing of light has taken place. This too has light harvesting complexes, has absorbed the light, then splitting of water molecule. Because of this absorption of light, water molecule has split, and when this water molecule has split, what it has, that is, it released the oxygen. It released the oxygen, and with the release of oxygen, we have also got here this ATP is formed, because when this electron was moving down this gradient down the hill, it released, when it reached this last electron acceptor, it has released the energy, and that released energy helped in binding this ADP with an inorganic phosphate, thereby forming an ATP. So, ATP is also formed, and here when the water molecule split, it released this proton also. This proton has been taken up by this oxidizing power, that is NADPH, that is NADP plus. Now, with the addition of this protons, it has changed to NADPH2, and this reducing power. So, at the end, absorbed light has been absorbed, water has been split, this oxygen has been released. Now, the only thing which is left at the end of this light reaction is we have this ATP and NADPH2. We have this ATP and this reducing power. At the end of light reaction, what we have got is oxygen, ATP and NADPH2. At the end of light reaction, what are the products of light reaction? At the end of light reaction, we have got oxygen, ATP and NADPH2. Okay, O2 has been released. O2 has been released. Okay, oxygen has been formed and it has been released. So, it is not present. It has been formed. Product is there. Oxygen is formed as the product of light reaction. Product has been formed, but it has been released by the plants in the atmosphere. Okay, so now O2 has been formed, but it has been released. But the only thing which is present now inside the plant is this ATP and NADPH2. And with the help of this end products of this light reaction, that is ATP and NADPH2, then here it enters into next phase of photosynthesis, that is dark reaction. So, now in this light reaction, we have got ATP and NADPH2 and oxygen has been released. So, now this is how light reaction will take place, and this is called as the Z scheme of light reaction. What it is called as? Z scheme of light reaction. So, during light reaction, what has taken place? Light has been absorbed, ATP has been formed, water has been broken down, oxygen has been released, and NADP, that is oxidizing agent, has been reduced with the addition of protons from the water molecule. So, thereby forming NADPH2. So, this ATP and NADPH2 are the energy rich intermediate compounds. So, these are the intermediate compounds. With the help of these intermediate compounds, final compound, that is glucose, is formed in the next phase of photosynthesis, that is the dark reaction. But before we move on to the dark reaction, let us see what is cyclic and non-cyclic reactions. What is cyclic and non-cyclic reactions in the next video.